solving problems using the quadratic formula. We're talking about the equation y equals ax squared plus bx plus c and all the forms that it comes in. Now, the y equals ax squared plus bx plus c is useful in the sense that we can, first of all, find the roots or the x-intercepts or the zeros. And in order to do that, we let y equal 0. And we factor if you can. Now, if you can't factor, you're going to go and use the quadratic formula, as you see on the left column there, as I've highlighted. Now, when we're talking about maximum and minimum values, we can convert to vertex form either by finding the hk value by finding the midpoint or of the x-intercepts, or completing the square. To find our vertex form. Any of those ideas are acceptable. Okay, now when we talk about values that are elsewhere on our graph, we're talking about either the x values or the y values. Now, if we have an x value, all we do is sub that x value into our equation. Now, if we have a y value, what we're doing is we solve the y value by plugging it in and then moving it to the other side to make it look like this. 0 equals ax squared plus bx plus c. And what that allows us to do is it allows us to either factor by grouping, factor using the simplified form, or factor using the quadratic formula. Okay? And that's it. So this problem says we have the product of two consecutive even numbers is 524, right? To start this problem, you have to start with a let statement. The let statement is this. You let x be the first number, and so x plus 1 is the second. Does that even make sense? I don't think so, right? It's got to be x plus 2 because it's the next even number. So if I had 2, the next number would be 4, right? If I had 4, the next number would be 6. And so it's x plus 2 because of this even number thing that we were talking about here. Now, in order to do this problem, it says the product of those two numbers is 5624. So you're going to say 5624 is going to be the multiplication of these two things. Now, the multiplication of those two things is represented by x times the quantity x plus 2. Now, in order to do this problem, you must expand first. Then, remember that every time we're solving for something, we need to have 0 equals ax squared plus bx plus c. You must expand your information, then you're going to get something like this. But it's not in the right form. Remember, we need it to look like this thing here in order to solve for it. So in order to solve for it, we're going to take this 5624 and we're going to move it to the other side of our equation to get negative 5624 in addition with the x squared plus 2x. From here, you say, okay, I need two numbers that multiply to negative 5624 and add to, holy crap, that's ridiculous. I can't figure that out. So you know what you're going to do? You're going to take this and you're going to identify your a, b, and c, and you're going to use your quadratic formula. And we're going to go through and we're literally going to follow our pattern that we did before. We substitute in, right? B squared minus 4ac. We get this. Now, when you calculate the second half of this equation, you see the stuff that I've underlined here. You basically take negative 4 plus 1 times negative 5624. Whatever number you get is either going to be positive or negative. And then all you do is you write it like this. Done. And then your final answer is b squared minus 4ac is 2250. And that means there are two roots, doesn't it? Now, because there are two roots, we got to use this thing. Our quadratic formula, right? Now we're going to take all that information that we learned, And we're going to plug all that information into our solution. So now you're going to get, well, x is equal to, you get -2 because b was 2 and it's negative b in the front. We got plus or minus whatever that square root number is, plus 2 because 2 times 1 gives us 2 and a is 1. So now when we simplify, we end up with -2 plus 150 all over 2. That problem now splits into 2 parts. Now it splits into 2 parts, and those solutions are literally going to be this. X equals -2 plus 150 over 2, or x equals -2 minus 152. And we say that these are the solutions. And only for the x value. And now when we simplify, we end up with x is 74 or x is -76. So in this case, it says one of my x values is 74. Right? So what would the next consecutive number be for 74? And if you're thinking it's 76, you're correct, because we added 2. Now you remember at the beginning, we started by identifying the fact that we had our second consecutive number being x plus 2. We're using that to calculate the combination of numbers for x. So now, the possible consecutive integers are, for the first one, if x was 74, we got 74 and 76. For the other one, we've got -6 and -74. And we are done. Now, remember, always put the concept that you have to go and back substitute that information into our original let statements to find what we're looking for. This problem gives us a right angle triangle, right? So it says one side of the triangle is 1 centimeter shorter than the other side, right? We could use minuses or pluses here, right? To make your life easy, you're going to let the shortest side be x, right? So if you look at this problem, you've got the following. Okay, so let me just highlight that information for you. One side of the right triangle is 1 centimeter shorter than the other side, right? And the length of the hypotenuse is 9 centimeters greater than the shortest side. So I'm going to use the shortest side as my let statement. But the first thing that you have to do is you have to draw a picture of what's going on. Okay? Now, when you draw your picture of what's going on, you're going to get something that looks like this. So there's your triangle, and I'm going to say let x be the shortest side in centimeters. And there's x. I'm letting x be my base. So now this other side, the altitude, it says one triangle is 1 centimeter shorter than the other side, right? So if it's shorter, doesn't that mean that if this is the shortest, doesn't that mean that the altitude is going to be x plus 1? So now that we've got that, we just got to go and determine what our hypotenuse is. The shortest side was 9. The shortest side was x. So to get the hypotenuse, we're going to have x plus 9. Now, in order to do this problem set, you got to start by using the Pythagorean theorem. Ready? Here we go. We got c squared equals a squared plus b squared. And now we're going to substitute our information in for the sides. So we have this. There's a reason why we studied this song. Remember this song? Square the first, square the last, multiply and double. You guys all look at me like I was nuts. Let me tell you why. It's because of this. There's so many times we have to do this. So you're going to sub in your sides, and then you're going to expand. And because we have that trick, we don't have to go and do simplification. So when we expand the left side, we're going to get 81 plus 80x plus x squared. And then it's equal to x squared plus 1 for that second bracket. And then we have plus x squared. Now, the next phase of this, we need to remember, we always have to take our equation and make it look like 0 equals ax squared plus bx plus c in order to solve. So we're going to have to move all this stuff over to the right side. And so now we end up with something like this. 0 is equal to x squared plus 2x plus blah, 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 minus 81. And now we collect our like terms. So we got x squared left over, minus 16x, and minus 80. So you could either use quadratic formula, or you could use your factoring. This is a simple factorization. Two numbers that multiplies to negative 80 and adds to negative 16. And those two numbers are going to be negative 20 and 4. So now this factors into this. 0 is equal to negative 20, x, and then x plus 4. So now that I've got that solution, all that's left to do is tell me what the solutions are. So the solutions for x are this. X equals 20 or x equals negative 4. Now, if I look at my triangle, you'd have to think about it. In the triangle, is it possible to have a negative distance? No. So we're going to say that's impossible for that one. We're not going to use that one, but we have found our sides. Now, based on our sides, you should be able to tell me what the sides of the triangle are. So the shortest side is 20, the second side is 21, and the third side should be 29. And we're done. And it's always important to refer to your picture to actually find the stuff that you're looking for, because this problem asked us to find all the lengths of all the sides. And make sure that you say that it is. Are these in centimeters, meters, or centimeters? Let's make sure. At the beginning, it says... It doesn't say. Yeah, it doesn't say. So these are just units. 21, 20, 20, and 29. So now let's move on to our next problem for the day. So now we have a rectangle that has dimensions of 3, 1, and 4, and 2x minus 5. The first thing that you do is you're going to draw your picture, because a picture is 1,000 words, right? Now, it says the area is 1,150 centimeters squared. So what I should do here is I should say, let x, we're going to say, just put here x is in centimeters. So we know what this means. So now you know that the area of any rectangle, it asks us for the area. It gives us the area, and we just need the dimensions. So area is equal to the multiplication of the dimensions, right? And then what we do is we substitute everything we know. So you get 1150 equals 2x minus 5 and 3x plus 1. So expanding, you get this. Now simplify to get this. And then we want it to look like 0 equals ax squared plus bx plus c. So we need to move the 150 over to the other side. So now we're left with this. Substitute. So once we've identified A, B, and C, you need to go and calculate your quadratic formula. Now, the reason why I went straight to that is because, you know what? I don't know what numbers multiply to negative 1,155 and add to negative 13. So we just go straight to quadratic formula. So when you do that, b squared minus 4ac is this, which means we have two solutions for our x value. Now, when you do part 2, you're going to start by subbing all that information into your equation. So you get something like this, which breaks down. Now, the square root of 27,889 simplifies to actually 167. So now our solution turns into this. Now, as for our final calculations, you're going to say, you're going to get these two values, but they don't mean anything to us because we have to find lengths. So we need to simplify and come up with the approximate roots or approximate solutions. So in this case, our solution is x is 15 or x is negative 12.83. Now, negative 12.83 doesn't work because if you take a look at the original equation, if you take at this part where we have negative 2x, when you plug that in, you'd end up with like a negative sign for everything on the right side of our rectangle, and that's impossible. So we can't use that solution. Okay. Now, once we've done that, we need to identify the solutions for all the sides. So in this case, for rectangle side 1, we end up with 3x plus 1. Then we're going to substitute x is 15 in, and we end up with x is 46 centimeters. Remember, we said that our original was x is in centimeters. And we'll do the same for rectangle side 2, and we end up with this. We end up with 25 centimeters. And we're done today's work. Now, next day, we're going to go and finish up the last 2 examples, and then we're going to start thinking about review for our test. Now, make sure you work on these specific questions. Before we move on to the homework, this is example 3, i.e. example 4 on our sheet. I used to call this was example 3 from lesson 5.2. This is where we were actually calculating the solutions for this rectangle, this pool. So we have a pool that's 10 by 20, and then we want to increase the area around it by a width of x. Okay? Now, in order to do that, we're ending up with sides that are 20 plus 2x and 10 plus 2x for the bigger rectangle, and 10 and 20 for the inner rectangle. So when we calculate the area is given by this. Area of big minus the area of small, blah, 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 and we end up with this. 4x squared plus 60x. Now, she says she can pay $1920, but can cost that much. So this is where we did that money calculation to figure out how many tiles she could pay for in area. And then we did this calculation where we solved for 0 equaling 4x squared plus 60x minus 64. Then we did a GCF of that and then factored accordingly. Now, we notice that x is negative 16 is impossible, and then x is 1 is a solution. So we use that in our solution to find the width of our new calculation. Now, we could have also used the quadratic formula here, but we chose not to. Now, this is what I'm trying to give you. The concept that when we go and solve for quadratics, we can either use the quadratic formula or the regular factoring that we used before, or factoring by grouping, or the Berry method to get our solutions. All are acceptable. Some are faster than others. It comes to you to make that decision when you're solving. Okay, and now your homework for the day. Your homework for today is dealing with word problems. I want you to work on consecutive numbers. The consecutive numbers, maximizing revenue, area of a triangle, and the increase or decrease in the area of a rectangle. We have done maximizing revenue. Okay? Now, all I want you to do is just work through this and see what you get. Okay? And that's it. Do that homework overnight, and we'll continue on with the lesson tomorrow.